Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 15, 2025, just 2 days ago. The standout result is a Coq-verified proof that S of 5 equals 47, 176, 870, finally settling the fifth Busy Beaver step value. The paper is titled, Determination of the Fifth Busy Beaver Value. And as we will see, the verification pipeline and its scale are pretty remarkable. Beyond the headline, the work also certifies sigma of 5 equals 4, 098, and S of 2, 4 equals 3, 932, 964, while explaining how a carefully reduced search space and formal deciders close every remaining case. On X, posts share the announcement and link, with one playful line saying it is Busy Beaver Day, and others simply repeating the title and pointing to discussion threads. Engagement looks modest, with single-digit likes and no visible repost surges. Alright, the previous segment highlighted the headline results and their verification. Table 1 now maps the small Busy Beaver landscape across states and symbols, which makes the new boundaries crystal clear. The bright green entries mark S of 5 equals 47, 176, 870, and S of 2, 4 equals 3, 932, 964, because those were newly proved. The other green cells indicate values with formal proofs, while the orange cells signal open cryptids, meaning machines whose halting status is still unresolved and believed hard. So the previous figure summarized known values and open gaps. Figure 1 shows the 5-state champion in 3 panels, which together explain why the step count grows so large. The left panel lists the transition table, where colors mark states and the dash at eon 0 means halting. The middle space-time diagram traces the first 45 steps, so the colored head path reveals the state sequence. The right diagram stretches to 20,000 steps, which exposes the nested arcs pattern that repeats at larger scales. Okay, the previous figure highlighted the 5-state champion structure. Figure 2 shows the 2-state, 4-symbol winner that halts after 3,932,964 steps. The left panel lists its transition table, which encodes how the head writes, moves, and switches state for each symbol. The center space-time strip shows the first 45 steps with colored head positions, so the zigzag path becomes clear. The right panel zooms out to 20,000 steps, revealing large arch-like sweeps that repeat at broader scales. So the previous figure focused on space-time behavior. Table 2 reports how tree normal form slashes the search space, which matters because the proof must check every 5-state machine. The table lists non-halting counts, halting counts, totals, and the syntactic to TNF ratio. The headline is the 5-state row, 181,385,789 machines, with a 91,958-fold reduction. Those ratios show why the queue-based enumeration remains tractable. Alright, the previous table quantified the TNF reduction. Table 3 lays out the full S of 5 decision pipeline, which lists each decider and how many machines it resolves as non-halting or halting. The loop stage dominates with 175 million decisions, so the remaining methods mop up hard edge cases. Finite automata reduction and its weighted variant add just 40 decisions, which shows their precision matters more than volume. The long halters pass certifies 183 halting champions, and the 13 sporadic machines require bespoke proofs. Wrapping up, 2 takeaways stand out. The team nails S of 5 equals 47, 176, 870 with a fully checked Coq pipeline, and the tree normal form plus targeted deciders make a gargantuan search auditable. The broader implication is clear. Community tools and formal proofs can settle famously hard combinatorial frontiers. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.